In this lesson, we will explore quantitative forecasting techniques and their critical role in predicting future demand. Quantitative forecasting uses numerical data, statistical methods, and mathematical models to make informed predictions about future sales, production needs, and market behavior. These techniques help organizations manage inventory, optimize production, and align supply with demand through data-driven decision-making. One of the most fundamental quantitative forecasting methods is the moving average technique. This approach calculates the average demand over a specific number of past periods to predict future demand. For example, a 3-month moving average adds the last 3 months of sales and divides the total by 3 to forecast the next period. Moving averages work best when demand is relatively stable without significant fluctuations. They smooth out short-term variations and highlight longer-term trends. Another widely used method is the weighted moving average. Unlike the simple moving average, this technique assigns more importance to recent data by applying weights. For instance, more recent months may be given higher weights because they better reflect current market trends. Weighted moving averages are especially useful when recent demand changes rapidly, making them more responsive than simple averages. The exponential smoothing technique builds on this idea by applying exponentially decreasing weights to older data points. This method gives the highest weight to the most recent observation while still considering past data. It is simple to apply and requires less historical data than moving averages. Exponential smoothing is particularly valuable when demand follows a consistent pattern but may experience random short-term variations. Another key quantitative method is regression analysis. Regression forecasting examines the relationship between demand and one or more independent variables such as price, season, or advertising spend. For example, if sales are influenced by marketing efforts, a regression model can help estimate future sales based on projected advertising budgets. This approach helps identify demand drivers and supports more strategic decision-making across departments. Time series analysis is another cornerstone of quantitative forecasting. A time series represents data collected at regular intervals over time. Analysts study patterns such as trends, seasonality, and cycles within the series. For instance, sales data may increase during certain months due to holidays or weather patterns. Decomposing the time series into these components helps companies adjust their forecasts for seasonal effects and underlying growth trends. Causal forecasting models take regression one step further by exploring cause and effect relationships between variables. For example, an increase in raw material costs may influence product pricing, which then affects demand. By understanding these relationships, businesses can simulate how external changes impact future sales and adjust their operations accordingly. Another important method is econometric modeling, which combines multiple statistical techniques to forecast complex economic and business phenomena. These models incorporate several variables, such as GDP growth, consumer income, and inflation, to predict demand in industries affected by macroeconomic trends. Econometric models are often used by large organizations and governments for long-term planning. Finally, advanced forecasting techniques like machine learning and artificial intelligence have revolutionized quantitative forecasting. Algorithms such as neural networks, decision trees, and support vector machines can analyze vast datasets and uncover patterns that traditional models might miss. AI-powered forecasting systems can automatically adjust to new data, making predictions more dynamic and accurate over time. Each of these quantitative forecasting techniques has its strengths and limitations. Simpler methods like moving averages and exponential smoothing are easy to implement and suitable for short-term forecasts. More complex techniques like regression and machine learning provide deeper insights and adaptability, but require more data and computational resources. The key is to choose the right method based on the nature of demand, data availability, and business goals. In summary, quantitative forecasting techniques enable organizations to transform data into actionable insights. By leveraging mathematical models, statistical tools, and advanced technologies, businesses can reduce uncertainty, improve planning accuracy, and create more responsive supply chains. Mastering these methods empowers decision makers to anticipate changes, allocate resources wisely, and maintain a competitive edge in a fast-moving marketplace.